All right, question number 15. We want to find the equation of the tangent line at the given value of x, and then use the graphing utility to graph it. So we are given y equals 8 times sine of x times cosine of x, and our x value is pi over 3. So we need a couple things. We first got to find the y value because we need an ordered pair to plug in to find the equation of the tangent line. And then we got to find the derivative and then plug in this x value and find the slope. So we're going to plug this x value into the original equation to find our ordered pair. Instead of x is going to be pi over 3, and then times cosine of pi over 3. And then you can refer to your unit circle. I'll just point it out. We are going to be given coordinates. Sine is x, cosine is y. I have pulled up our trig cheat sheet from our course just to kind of refer to you. Unit circle is a circle with a radius of 1. And using Pythagorean's theorem, we get these ordered pairs, but they just show you sine of an angle is the y coordinate and cosine right here is the x value. So the value we are looking for is pi over 3. So the x value, cosine of pi over 3, is going to give us 1/2, and sine of pi over 3 is going to give us square root of 3 divided by 2. Okay, so plugging in pi over 3 is going to give us 8 times square root of 3 over 2, and then 1/2. Okay, multiplying straight across, think about this as 8 over 1. All the numbers on top get multiplied, 8 square root of 3 and 1. So it's just going to be 8 times the square root of 3 on the top, and then 2 times 2 on the bottom will give us 4. And then 8 divided by 4 is 2, so you get 2 square roots of 3. So my ordered pair, x is pi over 3, and my y value is 2 square roots of 3. So that's the ordered pair we're going to use. Now we got to find the derivative. So dy dx, you can say y prime, however you want to say it. Doing the derivative, we're going to have to do the product rule. We got two things in terms of x. So I'm going to factor out the constant 8, and then we're going to do 1 sine of x d2. Derivative of cosine of x is going to be negative sine of x. So 1 d2 plus 2, the second function, cosine of x. Derivative of the first, sine, is going to be cosine of x. And then simplifying, we get 8, and this is going to be my negative sine of x, and this is squared, and then plus, this is going to be cosine of x squared. Okay, so once again, if we refer to our unit circle, we're going to be plugging in the x value of pi over 2 to find our slope. So we'll have the 8, and then we'll have the negative, we'll have sine of pi over 3, and this whole thing is going to be squared. Not the negative, it's still going to be negative. This is squared, and then plus cosine of pi over 3, and then this value is going to be squared. All right, so sine of pi over 3 is going to give us square root of 3 over 2. So we're going to be squaring that. And then plus 1/2, and we're going to be squaring that. So doing so will give us 3 over 4 and plus 1 over 4. D2. This gives me a negative 3 over 4, and I still got my 8 on the outside. So whenever I combine these two, this is going to give me 8 times a negative 1/2, because it's going to be a negative 2 over 4 reduced to 1/2. Multiply times 8, that gives us a negative 8 over 2, and that reduces to a negative 4. So this is the slope, the M tan, if you will. M tan, slope of the tangent line. All right, from here we can now use the point slope form. Y minus y1 equals x times, sorry, not x, this is going to be a m, x minus x1, and we will plug in this ordered pair. This is the x value, this is my y value, and then this is my slope. So we'll have a y minus the y value of 2 square roots of 3 equal the slope, which is a negative 4, and then x minus the x value of pi over 3. So we'll get y equals a negative 4x. Negative times a negative is going to be a positive, so I'll just say 4 pi over 3 plus 4 pi over 3, and then we'll have additional plus 2 square roots of 3. I can probably try to combine those by doing a common denominator. You can leave it like this for now, but if you want to make a common denominator, negative 4x, top and bottom by 3, so we'll get plus 4 pi, 2 times 3 is 6, so plus 6 square roots of 3 all over 3. You can write it like so, but it's not going to change a whole lot. I'll just leave it in the standard form. So we get a negative 4x plus 4 pi over 3, and then we got plus 2 square roots of 3. All right, and then if we were to graph this, according to our equation, in part A, we got a negative slope, negative 4x. So if I was just not even having graphed it, this is a positive slope, this is horizontal, I would be looking at either C or D. I would want to say C, the tangent line is just going to touch it, you know, and touch at one point, but let's graph it just to confirm. So you can either use a graphing calculator or Desmos or some other form if you want. And we are going to graph this. So I'm going to clear out what I have, and they give me some things to change the viewing window as well. If you notice at the bottom it says make the viewing window negative 2 pi to 2 pi and 10. So we're going to go to y equal first. I'm going to clear out what I have here, and I'm going to type in this equation, negative 4x, and then I'm going to say plus, I'm going to make the fraction alpha y equal enter. If you don't have the operating system, just make sure you put the numerator in parentheses and the denominator in parentheses. So I'm going to say 4 pi over 3, and then plus 2 square roots of 3. And then in y2, I'm going to graph the original equation. So I graphed the tangent line first. I also need to go and get my original function, which I have to pull this down so I can see it. My original function was 8 times sine of x, and then times cosine of x. Okay, so we got all of that plugged in. We're going to go to window. Okay, so if I graph it right now, I'll just go ahead and graph it right now. It won't look exactly like any of these graphs. Maybe not, because the window isn't the same. Maybe it looks pretty close anyway. Based on this image, I would pick a D. But if you go to window to make it look exactly, we're going to change this to negative 2 pi. And we're going to change the max to positive 2 pi. And the calculator just automatically converts it to decimal form. And then the Y is going from 10 to 10. So this will just change how far the graph goes. So once you graph it, give it some time, and so now it looks more exactly. You can see the same number of waves. So again, I would have just guessed C because tangent's going to touch it at one point. However, according to this, we are getting D.